are condensing this expression to get warmed up today. How do we do that? What's the first thing we need to do to condense this? Do we see parentheses?
Nope.
No, we do not, okay?
There's letters, or there's numbers in the front. So
Numbers in the front. So those become what?
The top thing, so like the squared and the things.
Exponents, yep,
yeah.
you got it, okay? So the 3 is going to go and be the exponent on the x. The 2 is going to be the exponent on the y. The z doesn't have anything, right?
Yeah.
Okay, cool. So this becomes log of x cubed plus log y squared minus log z. You with me?
Yep.
Okay, now what do we get rid of?
Yeah, I don't remember.
Well, we're condensing. We need the word log just written one time, right?
Yeah.
Yeah. I see it written 3 times. So can we have these plus and minus? Addition, subtraction. What do we change those to? Multiplication and division. Okay, so for the first one, we write log. I would change this plus sign to multiplication, right? So what am I multiplying? The whole thing, not just the exponent. So the variable's 2. So x cubed y squared. And then the subtraction sign means to divide, so I'm dividing by
Log z or z.
just z. Yep, because we don't have to rewrite the word log.
I'm guessing that's going to be it 'cause you can't do anything.
That's it. Yep. That's all. Okay, so hopefully we knew that one. If we didn't, chances are you didn't do day 2 homework, so you might want to go back and do that. We do have a test. It's not coming up quite yet. Probably not next week, but I think it'll be the week after. So put that on your radar. Okay. Any homework questions from 9.3 that you would like to go over? Yes. 5. Let's see what it is. Okay, so 216 equals 2 to the x power minus 11. Okay, so we notice, do we have exponentials on one side or both?
Oh, 1.
Just one is what I see, okay? I just see it on one side. Is it alone on that side? No, it's got something else hanging out. Can that be over there?
No.
No, what does it need to do?
Add it over.
We need to add it over, good. What is 216 plus 11?
227.
Equals 2 to the x. And now can we set up something to solve this? So since it's an exponential, we have to set up its inverse. The inverse of an exponential is a log. Log, yep. Okay.
Yeah, sure.
So how do we write a log?
Question, you know?
How do you spell log? What'd you say, Brooke?
227 divided by log 2.
Okay. Super close. So log base 2 of 227 equals x, and then you did log 227 divided by log 2. Good. So we just got to make sure we write down all the steps. And what is log 227 divided by log 2? 7.84. Cool.
Zach, you keep looking back here, I swear. Because every class,
Every class.
yes, anytime I do something wrong, he'll come and looking back and smiling at me.
I don't think you did it wrong. You did it right. First shot. Yes, Jaden. Number 11. Number 11. If you don't have your homework out on your desk, I just gave away a free answer and I'm about to give away another one. So it's really not good if you're sitting there doing nothing. Okay, 7 to the x power equals 24. Okay. Exponentials on one side or both? One side. Okay, so I need to set up a logarithm, right?
Yeah.
It's alone on a side. So I need to write what? Log base 7 of equals x. And I type this into my calculator by doing what? Perfect. Log A divided by log B. Log 24 divided by log 7. And what is that? 1.63. We all agree with that?
Yep.
Anyone check that one? Braden, you checking it right now? I hope that's why we have our phone out. Because if it's not, we should probably put the phone away. Yep. Okay.
I'm just waiting to do the notes.
You're waiting to do the notes. You're ready? Okay, cool. Is everybody else ready?
Yes.
Did that help answer your question?
Yeah.
Okay, cool. Alrighty, here we go. 1 page of notes today. That's it. It's actually less than a page. Still gonna take us a hot minute, but we'll get through it, okay? So, we have solved exponential equations, right? Okay? We know the inverse of exponentials are logs, so now we're gonna be looking at solving logarithmic equations. So, what we want to do is just the same steps as what we did with exponentials. Okay, we want 1 on each side. Okay, and if they have the same base for these logs, then we can go ahead and just set their a values equal to each other. So what I mean by that, this very first example here, do we see how we have 1 log written on each side with the same base? That's what we want. Okay? Because when that happens, it's the easiest thing ever. We can just set these a values equal to each other and solve. So 5x plus 9 equals 6x. Write that down, Zach. And how would we solve an equation that looks like that? Say what? Yep, subtract the 5x. And what is 6x minus 5x? Just x, so my answer is x equals 9. That's it.
I mean, that's easy, Zach, 'cause we all know how that goes.
Okay, any questions on that? Okay, here we go. Do we have 1 log on each side?
Yep.
Yes, with the same base.
No.
Actually, yes, it's 10, it's just not written, okay? But do we have anything written on there that's not supposed to be where it is?
2, that 2.
That 2 can't be in the front, okay? We need LOG equals LOG. We can't have numbers in the front, okay? If there's a number in the front, where's it go?
On the back.
On the back of just this, right?
Sure.
Okay, so this is the same thing as log of x plus 4 squared equals log of 4. Okay? Cool. Now, can we set the a values equal to each other?
Yep.
Yep, we sure can. X plus 4 squared equals 4. Not done yet though, right?
Nope.
No. How do I solve something that looks like this? We got to go back to beginning of this semester.
Can you put that 2 into them?
We're not going to distribute the 2.
Okay.
Okay, but think about what the definition of squaring something means. If you square something, if I square a number, what am I doing? Timesing it by itself. So if I'm squaring x plus 4, what do we think that's going to be? You got it. X plus 4, x plus 4. And how would we simplify the left side then? How do we multiply that kind of thing?
And you just FOIL?
Yeah, you just gotta FOIL it. Our favorite thing ever, right?
Oh yeah, selfish out.
Okay. X times x. X times 4.
4x.
4 times x.
4x.
And 4 times 4.
16
Equals 4. Now what do you think we gotta do?
Combine like term.
Combine like terms. So we get x squared plus
8x.
plus 16 equals 4. Now what? Okay, so since we have an x squared, this one's going to be a trinomial, yeah.
Dude, that's
So
so
dope. Okay, cool. I like it. I think it's dope too. But can we do the x method yet?
No.
No, what do we have to do before we can? Yeah, that 4 can't be over there. That needs to be a 0, okay? So this is x squared plus 8x plus 12 equals 0. Now I want you to try x method and get your 2 answers here. So you might have to go up here. So go ahead and try that. And how'd you do the x method on this?
that's what I was waiting to do.
I want you to help me though.
how many got in class?
I want your help. I forgot how to do it too.
Does it 8 go at the top?
No, the 8 does not go at the top. Try again.
Might as well screw
Somebody help Brayden. Remind him.
At the top.
12 at the top, 8 goes where?
Bottom.
Bottom. So we need two things that multiply 12, add to 8.
2 and 6.
2 and 6, are they both positive?
Yep.
So my two factors are?
X plus 2 and x plus 6 equals 0. You set them both equal to 0, so it becomes x equals negative 2 and x equals negative 6.
Perfection. That's it.
Let's
That's
do it.
how we do it. Okay? So that one was a little lengthier than the last one, right? But still not too bad. Not too crazy. Okay.
No, warm it up.
Warming up. All right. Here we go. This is a lot like our warm-up on the left side, right? Okay? So what we need to do here, we need the log written once on each side before we can set their a values equal to each other. So on the left, you need to condense and then solve this one. You can do it. It's not that bad. So go ahead and try this one. Here we go. All right. So we said log can't be written twice on the left. We need to write it one time with the same base. What do we do to get rid of that addition sign?
There's multiply.
Multiply what?
The log, the x, and then the 8. So 7
Not the 8. The 8's the base. The 8 stays where it is.
Oh, it's just x.
Just x times 7. What is x times 7?
7x.
Cool.
Oh, that's perfect.
Equals log base 8 of 42. So now, do we see that our log and our base is the same? Yep. So now what are we able to do? Cancel those out and just set the a values equal to each other.
Are you kidding me?
Are you kidding me? Told ya. We are overthinking these big time. What can we do? Divide the 7. And what is 42 divided by 7? 6. Good job. You would make your 3rd grade math teacher proud with those division facts. Good. Okay. This one is going to work very similar, except for you have to condense not just one side, but maybe the other one too. Okay? So go ahead and try this one.
Done.
Think about subtraction. What do we do to condense that? And think about addition. We just did that. What are we going to do here? What are we going to do?
Some math.
We're going to do some math. Yeah, agree. So start with the left side, because we work left to right. What can we do over there? So what would you write?
Log 72 divided by 4.
Perfect. And what about on the right side?
So you're gonna write log, and then you're gonna write
6x minus
6 with a parenthesis, x minus 2.
Perfection, Timmy. You should be a math teacher. You got it. Got a good projective voice, too. Okay. Now what can we do? Someone besides Timmy help me out.
Come on, Brayden. You got the dog?
skip that stuff.
You skip this step? Okay.
Can't you divide
No.
the 72 by 4?
Yeah? And what do you get?
Nobody else do it. 18.
18. Okay.
And then you can times that, put that 6 into that x minus 2, so it's 6x minus 2.
It's 6x minus 12.
Oh, yeah.
There you go. I don't need to write the logs, right? They canceled each other out.
Yep, that's
So
it.
18
Oh, wait,
equals
no.
6x minus
Add that
12.
12 over.
Add the 12.
You get 30. And
30.
it's x equals 5.
Because you divided by 6.
Yep.
And you got x equals 5.
Yeah.
How many of us got x equals 5?
Because 30 divided by 6 is 5.
I should see more hands than that. I walked around and I looked at your papers. A lot of you had that. Okay. Good. Good, 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 good.
I don't have to turn around and be like,
So, confidence level 1 to 5. How do we feel about logs on both sides?
what?
Confidence level 1 to 5. We're feeling like 3s, 4s, and 5s. Okay. We'll have more practice when we do homework in Delta Math today. All right. And then we have, when we only have logs on one side, okay? So if we remember, back to exponential equations. So we're actually going to real quick go off to the side and just do a little warm up here. Okay, so let's pretend that I have 2 to the x power equals 3. I do have extra room. Okay, you don't have to write this, but let's just do it together. So I have to take the inverse of an exponential, right? Because I only have an exponential on one side. So we would write a log. So we do log base 2 of 3 equals x, and then we type that in our calculator and we'd be good to go, right? Okay, so these are going to work the opposite way. So if I have a log on one side, I get it by itself, okay? So it should be the only thing on that one side. And then I'm going to set up an exponential. Woo, yay, cool. All right, here we go.
Can you go back to that writing real quick?
You don't have to write it. It was kind of like the ones we did on the homework today.
Oh, I don't know.
You can write it if you want. Okay, Timmy. All right, so we all see that this log is alone on one side with nothing else hanging out with it. Okay, and it's the only log in the problem. Cool. So here's what we're going to do. We're going to take the base, which is 5. It's going to have an exponent of 3. And we set it equal to the a value of 6x. Can I solve something that looks like this?
Yeah.
Should be pretty darn easy, okay? The biggest thing that you might mess up on, it is not 5 times 3. It is 5 to the third.
125.
So 125, yep. You can type that in with the caret button on your calculator.
Or it just says x to the third.
Okay. Your calculator has that. I don't think theirs do.
Yeah, mine's cooler.
Okay, cool. Maybe everyone should get a calculator like Zach's.
Zach, she does not care.
I do care.
We do not care.
Okay. Now what do I do though? Because I'm not done.
Divide.
By what?
It's a
125.
No.
decimals.
Getting x by itself. Divide by what? 6. Thank you. What is 125 divided by 6?
20.8333333.
Okay, we'll call it 20.8. You can put it 0.833, I don't care. But you can round it if you want. How we feel about that? Good? Confident? We should. That's not that hard, okay? And we only have 3 more problems to do. All right, is this log by itself?
No.
No, what's hanging out that shouldn't be hanging out? The negative 10 in the front. How do I move it? Yep, since it's a subtraction, since it's minus, we're going to add it. Good. So we end up with log base 3 of n plus 3 equals negative 8. Yep, you should get 2. All right, so I want you to take it from there. I want you to go ahead and set that up. All right, here we go. How do I set this up?
You didn't do right, did you?
3 squared equals,
3 times 2.
what is 3 squared? 9. What do I do? Okay, and the answer is, how many of us got 6? Good. If you didn't, write it down, okay? Write it down. Any questions on that? All right, we got 2 more and we're done. Yes, Timmy.
I got 6.
Good job.
Let me let you know.
Thank you. Okay, third one. Here we go. Do it on your own, okay? Make sure that LOG is on a side by itself. Can't have any friends hanging out. Hint, hint.
I wonder if we still.
All right, so like we said, okay, as I was coming around, this one is not being added or subtracted. It's being multiplied out front. So we need to move it over by the inverse of multiplication, which is division. We're going to divide by negative 2. So we end up with log base 5 of 7x equals negative 1. Great. Now we set it up. Okay, so 5 to the... Hold on.
Why did we just divide?
Because it was being multiplied. So we got to move, like pretend that this was a variable. Okay, if I had negative 2x equals 2, I would divide the negative 2 over, right? So if that's what we have to do to figure out what our steps are, we can. Okay.
Yup.
So now we get 5 to the
-1.
negative 1 equals What is 5 to the negative 1?
Negative 5.
No.
I don't know, 5.
Type it in. Come on. Yep, 0.2. 0.2 or 1/5. Whichever way.
No fractions.
No fractions? Okay, we'll keep it decimals just for Carson.
What the heck is this number?
Okay, what do we do now?
0.02.
Divide by what?
7.
7, and you get 0.02.
Yep. Oh. That's extremely good.
Okay. Thanks for your opinion, but it's irrelevant. JK. Alright, here we go, here we go, here we go. Is this, do we have logs on one side or both?
Both.
Ah,
1.
one side, okay, but is it written one time? Is it written one time?
No.
It's written twice, so we must
Combine.
condense. Yep, combine, condense, whatever you want to call it. So, this is addition. We know what goes with addition. There's your hint. Go ahead and try this. Okay, so on the left side, how do we condense that?
I might get log.
Yeah, gotta figure it out.
What do you mean you couldn't figure it out?
Log
Log 8, that's the first step. And then how do we get rid of a plus sign?
multiplication.
Thank you. So we multiply what?
8x.
Yep, 2 times 4x squared is 8x squared. And now we've got one log isolated on one side, but not on the other, so we must set up an exponential. What's our base? 8. What's our exponent? Equals.
8x squared.
What is 8 to the first?
8.
Now what?
5.
By?
8.
What's 8 divided by 8?
1.
1 equals x squared. How do I get rid of a square?
I don't know.
You have to divide by the
Square
square.
one.
Yep, the square root symbol. Good. What is the square root of 1?
1.
And negative 1. Yep, those are my 2 answers. Okay,
Hey.
that's it. Delta math homework. Get on it, get on it, get on it.